Hello friends. So today we are going to discuss another question on the Rn method of the definite integration. So the question is this: limit n tend into the infinity factorial n upon n to the power n whole to the power 1 by n. Now if we simply just write the terms that we have over here, just simplifying the terms, we have n factorial. So we have n into n minus 1 into n minus 2 till 2 into 1 upon n to the power n. So we can write it as n into n till n times whole to the power 1 by n. Now whenever we are stuck in such a situation when we have terms in the multiplication and a 1 by n to the in the power, so we actually replace this term by an x. We take x as n as 1 into 2 into continues to n minus 2 into n minus 1 into n upon n into n into n till n upon 1 by n. Now since we have a 1 by n, whereas in the form that we discussed of the Rn method we had a 1 by n outside the summation sign. So now to get this 1 by n we actually use the property of the logarithmic. So we have a log, so we introduce log over here, and by introducing log over here we also introduce log in this side. So we have 3 till n minus 1 into n upon n into n into n upon 1 by n. Yeah. So now using the properties of the log, we can take this 1 by n out of the log by, since this is in power, so we can write it as 1 by n log 1.2.3 till n minus 1 into n upon n into n into n into till n. Now we need to use the logarithmic properties again, which we know that we can actually just simplify this further by separating the terms 1 by n into 2 by n into 3 by n and just go on to n by n. And now since these terms are in multiplication we can separate them as plus sign in between. This is a property of log, we know this, so I'm just directly gonna write this, and this is what we get: 3 by n continues to log n by n, and we have a log x over here. Now we are just gonna convert this into our recognized form, which is r is equals to 1 to n, and we have a log r by n. Now when we put 1 we get this term, when we put 2, and so we subsequently get these terms in a row. Now what we are going to do is, since we have converted this into this form, now we are going to convert it into definite form, and we have a 0 to 1 here, and log x dx. Now here, if you remember my video on the by parts series, we actually need to integrate this using the by parts, since these two terms are in multiplication, so we can take it as f1 and this as f2. And now just simply integrating. I have taught this way of integrating in the my series of by parts, you can watch that. So I'm just gonna apply that concept here. We have x log x integration of 1 dx minus integration of differentiation of log x upon dx into integration of 1 dx and whole dx. So this is the form we get. I have actually taught this form in the previous videos of mine, so I'm just gonna write the answer, and we have minus integration of, now integration of 1 is x and differentiation of 1 of log x is 1 by x, so we can cancel these terms out and we get x log x minus x. So this is one of the most commonly seen forms. We see this form very common, so we are gonna remember this formula and we are just gonna put the values in it. So the limits are 0 to 1, so I'm just gonna put the values of 0 to 1. Now putting 1, we get 1 log 1 minus 1. This is the upper limit minus lower limit, that is 0 log 0 minus 0. Now log 1 is 0 as we know, so we get a minus 1 over here and 0 into anything. So now we have log x is equals to minus 1, and we are supposed to find the value of x because we have substituted x in the entire question. So we need to find the value of x, which is very easy now. So we are again going to use the logarithmic property, and we have x is equals to e to the power minus 1. So this is our final answer. Thanks for watching.